Morning.
Good morning.
All right, so let's work on Trig 7. Did you guys try some last night? Yesterday?
Yeah.
Okay, so do you have any questions so far on anything? Let's see who's here. Okay. So all these questions we're talking about in Trig 7a, and they're very typical of the composition of functions, and we have to understand that these we've covered since one by one. We covered sine, arc sine, and it's a new function, and arc tangent, arc cosine, all of these. In addition to that, we covered yesterday about where it came from, and you need to understand that with these, right, this requirement is a condition for us to use this identity, which is the one-to-one function condition. And for the other one, it is oh wait, there's a negative sign here. It should be here. Okay, and all of these really come from the one-to-one functions property. Okay, so let's try a few. Okay, let's try a few to see if you really understand. I'm going to choose a couple questions for you. Okay, I'm going to choose a couple questions for you. And we did number 1. Anybody has any questions on number 1? Then how about you try number 2? Number 5. Number 9. Number 15. Number 17. Number 21, number 25. Number 21 and number 25. Okay, so let's first try these 7 questions. Okay. Number 2. Number 2. We got sine of arc sine negative 3/4. What does it equal to? We talk about 2 different ways to do it. And what do you check first? What do you check first? First, you check the input. First, you check the input. The input is a ratio. Okay, for arc sine, you know, the input is a ratio. The next thing you need to check is that is this ratio in the domain of arc sine? What is the domain of arc sine? What's the domain of arc sine? Right here. You follow me? That's the domain of arc sine. Everything we work with, if the input has to be in the perspective domain, if the output has to be in the perspective range, no solution to any function should be outside their domain or outside their range. Okay, that's the power of domain and range. So you constantly need to have those, we need to constantly have those domain range in our mind, right? We have enforced these from picture, from unit circle, right? All of these is enforcing these domain and range concept and how to read the individual points, how to read the individual points. What's the input and what's the output? Okay, so this is indeed in the domain of arc sine, okay? If it's in the domain of arc sine and it also satisfies, and that means we can apply this property. Okay, we can apply this property because the condition is satisfied, and therefore this would equals to -3/4. You guys follow me? So these properties on the top of Trig 7a, they're like they're like additional perks. They're like additional perks. Okay, all the other threes, sine, arc sine, all of these. Right, we have addressed them in details, and there's some interesting properties that from inverse functions, and that made these perks. Okay, you can also do it the other way. Okay, so let's look at number 5. Look at number 5. What do you think of number 5? Arc sine of pi/3. This sign, okay, this sign refers to which one? Always refer to the sign as we know it. Okay, it refers to this sign. Okay, but it happens that this pi/3 is also, okay, pi/3 is also in the, the restricted part, okay, from -pi/2 to pi/2. Okay, for sine, there's no domain issue. For arc sine, there's domain issue. Why arc sine has domain issue, sine has no domain issue? Tell me, why arc sine has domain? Why on this one, I will check the domain, and for sine, I didn't check the domain? It's because arc sine has a domain of between -1 to +1 inclusive, and the sine, the domain for sine is all real numbers. That's why we don't have to worry about the domain. Okay, because any number you put there is going to be, it's bound to be in the domain. Okay, it's bound to be in the domain. So what would this be equal to? Well, in this part, the input, which is an angle, will satisfy this condition. Therefore, that property would apply. So this answer would just be pi/3. Okay, then you say, well, what if I don't remember? What I forget? Yes, most of us probably will forget about these things, right? But you need to understand these are conditional. These are conditional. This statement and that statement is a conditional. They're conditional. So what we went through, that whole process is try to get you to understand that in the case you don't remember those conditions, maybe you can retrieve it. Or in the worst case scenario, you don't remember. Okay. So suppose for number two, you don't remember these. Okay, we're going to put this away. What are you going to do? I say, oh, there are so many things I have to remember, right? It's lots of information. What do?
You look for the domain.
Start from definition. That's where you go. Okay, so I'm going to take this picture that we did yesterday. Okay, then you need to know a few basics. Okay, so I'm going to show you. In the case that you are familiar with those properties, or in the case you're not familiar with the properties, what do? You go for ARD. You go for ARD. Okay, so you would say, okay, arc sine of -3/4. Okay, the input is a ratio, the output is going to be an angle. Okay, you guys follow me? I'm talking about a general methodology. Okay, this is the mean I'm teaching you. If you get it, and you can apply it, and you will be invincible. Okay, it's not a special angle, right? But you do need to understand. Arc sine takes ratio. The input is a ratio. Right? This is the thing I emphasize over and over again, right? How many times did I emphasize these?
A lot.
A lot. The least you need to understand that this is a ratio. Okay, this is a ratio. And this ratio will produce an angle. Okay, this ratio will produce an angle. Okay, and of course you can put a ratio here. It produces an angle. This ratio has domain and range. Angle has a scope. Okay, but this angle is going to be arc. What is the range for arc sine? Tell me. You still need to know some basic, right? You still need to know some basic. The ratio for arc sine is what? It's less than equals to pi/2. Okay, there's multiple forms I have given you over and over and over and over again. You are expected to be very familiar with it, guys. Okay, you are expected to be very familiar with each one of those forms because you never know which one professor is going to use. Do you follow me? So with this understanding, so I'm going to put this as think out aloud. Okay, I'm also going to give you a version of how you answer the question, how to present the answer to the professor, whoever she is or he is, to get your point. Okay, right now I'm just put this as think out aloud. When you think out aloud, you have to know what to think about, right? What to think about. So there's some basic stuff that I emphasize over and over again. Even you agree that I've emphasized those many, many times, every single day, right? That you know the input for arc sine is a ratio, and that ratio has to be between what? What does that ratio have to be between? It has to be between -1 and positive.
And 1.
That's right. So even though you say, I don't remember those perks, I don't remember those, whatever, you need to have these basic concepts. If you don't even have these basic concepts, all I can tell you is that you have to take trigonometry again. Do you follow me? Because I believe for most of you, for 100, well, actually not for most of you, every one of you should have taken trigonometry before. Okay. All right. So with this, okay, we think out loud and say, okay, so this is going to be an angle. So you're going to assume this is an angle. We call it theta. And you immediately know where theta should be. Theta should be where? Between negative pi over 2 to pi over 2. You see, I'm using these different forms interchangeably in my context. Did you notice? I'm using these different forms interchangeably in my context. Okay, can you follow me? You just need to be familiar with all of these things for different form, because every form, there's a reason for its existence. Sometimes for shorthand notation, and sometimes for different things. And over here, because the ratio is negative, then theta is in the range. In particular, you actually know it's going to be a negative angle. Okay, the DRA, right? DRA. So from this ratio, we know that sine theta is going to equal to negative 3/4. Sorry, negative 3/4. Okay, so what does it tell you? This is the handling of arc sine, right? You see, along the way, I'm using domain and range to guide me. Okay, and we know that when we're dealing with arc sine, these two quadrants are no use. And this angle theta is going to be measured from standard position counterclockwise or clockwise. Clockwise, right? Because this is negative. Negative ratio corresponds to negative angle in the arc sine case, right? And then the terminal is going to be somewhere here. Okay, approximately. So what will be theta? Theta is measured clockwise. So that is theta. This is how much information you need to know. You say, oh, I don't remember that. That's fine. That's fine. Okay. And next, sine theta equals to negative 3/4. Negative 3/4. What does that mean? Sine theta is defined as what? Whatever, right? Negative 3. Well, it's in the fourth quadrant, right? So this should be 3, negative 4. Wait, which one should be negative? Y is negative, right? So this is negative 3. And the hypotenuse is 4. You still need to use this in Calc 2, by the way. Okay, maybe a different number, maybe 5 and 9, maybe it's a negative 25/64 or something like that. Okay, so we know this angle. Now, with this said and done, okay, our initial question was to ask for what? We need to find sine of arc sine negative 3/4. Negative 3/4. Right? And that equals to, okay, another parentheses. Oh, this is a little bit awkward. Okay, that's nicer. Okay, and we have assumed this is theta, so we have sine theta. And what is sine theta? Sine theta is negative 3/4. So the answer to this question is really just negative 3/4. Okay, it's really just negative 3/4. And all these information we put there, they're useful, they're not terribly useful, because by this time you already recognize. So by using definition, By using definition, right? ARD, DRA, you can also get the same conclusion. You follow me? Do you want to try one more on the next one using definition? Okay, let's do that. The more you practice using this, the better you're going to be. The better you will be at ease. Please don't expect that you just watch it and you know how to do it. I don't know how many of you have that kind of expectation. If you can do that, you're pretty much a genius. Okay, you're pretty much a genius. And I certainly cannot do that. I got diamonds on my dial. Okay, so do commit yourself to paper, pencil, really work on it. So now I'm going to show you the work. Okay, so how do I show work if you do this? Okay, how to show work for this? Show work. Okay, so this is the question. You will say let theta equals to, or the other way around. Okay, you can totally use that. Okay, so like that. You basically introduce an intermediate variable. Okay, you can use pi over 2 here if you want. It's not wrong. It's not wrong if you use negative pi over 2 to positive pi over 2, that's okay. If you use negative pi over 2 to 0, that's correct too. Okay, it is just more, better, it's a better estimate, but you have reflected that you understand the, the situation. Okay, and then you will say, okay, sine theta equals to negative 3 pi over 2, negative 3 pi over 4. And then you say thus. Okay, you already have this, right? And that equals to sine theta. And that's equals to what? Negative 3 pi over 4.
Negative 3/4.
So even if you show work, this is really how much work you need to show. Okay, suppose you don't memorize that part, that's okay. That's not the end of the world. It's not the end of the world. When you show work, you can, in this situation, it's so simple that you can draw the picture or you don't have to draw the picture. Draw the picture will be, will be helpful, but make sure your work is well organized. Your work is well organized. Okay, I cannot say enough. That's how important it is to organize your work. Okay, I'm always asking people, please do your best work. Please show your best work to your professor, not just show any work. Your best work, your best work. Okay, I think that is just that's not just only for academic, it's for life as well. Okay, give your best, give your best. Okay, so when you need to show work, when you think you need to show work, you go through this journey, then this is how much work you need to show. This is how much you need to show. Okay, so let's look at the next one. The next one, and of course, you know the answer. Could you guys try to do it another way? You still go by definition, right? You still go by definition. But this time you need to understand the sine can take any angle. Okay? Sine can take any angle. Sine pi over 3, or you can do this. Okay, let me show you that. Some of you remember, oh, I know. So I just go layer by layer. Okay, if you don't remember that perk, this is arc sine. And sine pi over 3 is equal to what? It's root 3 over 2, isn't it? Yeah. And then the next one would just be pi over 3. You can go by this route as well. Okay, or you can go by, you could do it by using definition. So there are more than one way to roam. There are more than one ways to roam, right? That's true almost to every question. Every algebraic question, you always have more than one way to do it. More than one way to do it, okay? So these are the first two. Let's look at 9 and 15. 9 and 15. Okay, it gets a little bit more interesting, yeah? Number 9. Number 9, we have sine of arc sine, 3/2. What does this equal to?
It doesn't satisfy the requirements of sine arc sine x because it's greater than 1.
You're very close, but you may like to use the word for domain. Okay, because 3/2 is outside the domain of arc sine. Okay, is that what you meant?
Yeah.
That should be what you meant. Thank you for your contribution. Okay, the answer to that is very straightforward. You just go straight to the blood. Okay, 3/2 is outside the domain. Very good. But you need to express it correctly. The wording you use need to be modified a little bit. Okay, 3/2 is outside the domain. So what is the conclusion here? Undefined. Because 3/2 is outside the domain of arc sine. Give proper reason using the right vocabulary. Very necessary for your training. For example, in your calculus class, you need to say, oh, it's continuous, not continuous, using the definition of continuous, something like that. I have students in my calculus class, they were describing about continuity. They will say, oh, there's a hole. What do you mean a hole? What is a hole? Huh? There's no such definition for a hole in mathematics. You have to use the right vocabulary. You guys follow me? So I welcome all these contributions because these are the opportunities I can correct you if you don't mind. If you don't mind. And I will write it down. I will write it down for you. Okay. So this is precisely the reason. If you give this reason, everybody is convinced. So shut up. Shut up, everybody. That's what you wanted. Right phrase, complete sentence using the right words. You're not going to use words, in psychology for these, right? Mathematics has its own particular words, in there, right there. Okay, so let's look at number 15. Very good effort. Okay, number 15. We have arc sine. Sine of 3π/4. Okay, I'm going to make this a little bit larger. Would that be better? You can type, you can contribute. You can contribute on chat, you can speak out in words. And just be aware, I will be correcting because that's my job. There's more than one way to do it. Can we apply this property? Can we apply this property I highlighted?
Yes.
Yes? In order to apply that property, what do you have to do? You have to check this condition. This is a condition. It's a conditional statement. The answer is you cannot apply that property because 3 pi over 4 is outside that requirement. You follow me? So in order to, on all of these 3 rows, and there are 4 rows on the in the notes, there are conditions. These are conditions. Okay, in the handout, I say 4. Okay, 4 basically is the specifics. It's specifying only for these, only for if these conditions are satisfied. I use the 4 in the handout, but here I want to emphasize that condition. You cannot just use a half sentence without looking at the condition. All of these, among all six in front of you, 5 of them are conditional, and this one is not. This one is unconditional. You can see because x can be any real number, x can be any ratio. All other 5 are conditional. You follow me? So if you use them, you need to know that they are conditional. If the conditions are not satisfied, you are going to be making a mistake. Do you follow me? This involves how to read mathematics. How to read mathematics, right? So how do you read this? This basically tells you when x is between negative pi over 2 to pi over 2, this is true. And what does it imply? Otherwise, this may not be true. You follow me? So everything we see, everything we do, everything we read about, every statement that is being made, it tells you something is, it also tells us something that is not. Does that make sense to you? And this condition tells you when you can use it and also tell you when you cannot use it. You follow me? So you cannot use this. Okay, so here I'm going to put a note. Okay, cannot use that, even though not everyone of you would use it. Okay, cannot use this because what? Condition is not satisfied. Okay, since I'm going to use another symbol for you, okay, because I'm running out of space. Is there another little symbol for me? Some of these mathematical symbols, I feel I want to introduce them to you. It has made my life incredibly simpler from time to time. Some of these are given, okay? It's not here. And is it here? There. Okay. This little notation. Okay, 3 dots make a triangle, but this triangle is upside down, right? This 3 dots means because. Okay, I use this notation even when I'm not doing mathematics. Okay, meaning because. Okay, this is just little perks. If you use that in your calculus class, your teacher might be impressed. Where did you learn that? Right? Anyway, it's not a big deal. It's just little perks. Okay, you don't need those perks in life. Okay, so I'm going to put that away. Okay, some of you may think of using that property, some of you may not think of using that property. So I'm just addressing that issue that you cannot use this property because the conditions is violated. Okay, so what can you do? In the past, some student will tell me, oh, this is undefined. That reason is ridiculous because sine is defined everywhere. Okay. Another mistake I saw in the past. Okay, I'm just trying to point out as many things as possible. Okay. They tell me it's undefined. This is a terrible mistake. Okay. Not so. The domain of sine is all real numbers. Is all real numbers. Okay, so that reason is not correct either. But what can you do? What can you do? In this case, you just have to do it layer by layer. Okay, the most straightforward way to do it is doing layer by layer for all of these questions. Okay, whether you know the perks or don't know the perks. You know some basic, you know the definition, you just go by the basic from the inside out. Okay, so arc sine of 3 pi over 4, that is equals to what? What is that? Root 2 over 2, right? And then what is the arc sine of root 2 over 2? It's pi over 4. This probably will be the most common way of doing it. And there are other ways too. Okay, but you need to be aware that you cannot use this property. And this is it's undefined, it's not correct. Okay, it is perfectly defined. Sine 3 pi over 4 is perfectly defined. Just because you cannot use this property, you cannot say it's undefined. You cannot say it's undefined. It's perfectly defined. Okay, so this will be a standard way of doing it. This will be a standard way to doing it. Okay, so next, I'm going to have you guys try the last 3, right? Last 3, we just did 15, right? Now, the last 3 is 17, 21, 25. 17, 21, 25. I think by this time you have a reasonable orientation about what to do, right? Do you? 17, 21, 25. If any one of you wants to contribute something and show your work, okay, be aware when you show your work, Okay, this is what I like to see on your paper. You follow me? Write down nicely. Okay, we're online, we're teaching online, but I will give you, written quizzes and writing things down. I haven't done that so far, but I will. Is when whatever you write down, you need to write down very nicely. Well, if I were you, if you don't, okay, there might be consequences. Okay, there might be consequences. Okay, so always show your best work. Okay, this is also the reason why I want to type everything for you without using the handwriting. Okay, it's not my handwriting is terribly bad. My handwriting is very reasonable. But I think since we have the software to use at our hands, so I would just want to give you the best. I want to give you the best in typing. Okay, so in return, I expect you to show me your best. Okay, for that matter, you show your best to every professor you work with. $17. Okay, let's see what's on 17. $21. $25. -7π/6. You might be thinking, can we use that property? Can we use that property?
No,
Very good. Why?
it doesn't satisfy the conditions of the property.
Perfect. It doesn't satisfy the condition. Okay, every one of them, you cannot use this property because they're not in the domain specified. I'm sorry, not domain. It's not in the interval specified. Okay. -3π/4 is outside. 5π/3 is outside. -7π/6 is outside. So in this case, you cannot use these perks. What can you do? Right, the only thing you can do is just go with ARD. Okay, this is a negative angle, is measured clockwise because it's a negative angle, right? So you measure from the standard position. I'm speaking this, I'm not drawing the picture. Do you follow me? Okay, imagine a rectangular system here, right? You draw a clockwise angle, -3π/4 because it's a negative angle. That's the A. And then the R, you determine the R, and then you do the D. Okay, so what would that be? So you in your head, in your head, you're using definition. Okay, the terminal is in the third quadrant. And therefore, it's going to be a negative ratio. And that happened to be, you know, negative. It's a special angle. And then what? Arc sine. Arc sine of a negative ratio, you should expect an angle in the range of arc sine. So the answer is going to be in the range of arc sine. Here is negative pi over 4. You follow me? So although these are special angles, but you need to also think of domain and range. You think of domain range. Okay. Sometimes I get these kind of answers. Okay. For that, some student will give me 2 answers. One is negative pi over 4. And the other one is negative 3 pi over 4, for example. Sometimes I get 2 answers. Okay. Restore it. I mentioned this before, but I didn't talk about any examples then yesterday. The student gave me 2 answers. One is a correct answer, and the other one is incorrect. In this case, you are getting 0. Even though there's a 1 correct answer in your answer, you still get 0. Why? Because arc sine, okay, arc sine, okay, this function, it's a one-to-one function. One-to-one function for one input, for this one input, it should give you exactly 1 output, and you give me 2 output. You give me 2 output, that's a serious violation of definition of one-to-one function. On top of that, this demonstrates the student does not understand the range of arc sine. So I give 0. That was pretty nice. I could have taken 2 points off. Okay, do you see how serious that violation is? Violate concept of one-to-one function. This is how I grade your work, by the way. Okay, the way I grade your work, the criteria I use, they're all spelled out in the class. Reason, you know, every point I give you or every point I take away, I have a reason. And that reason is applied to everyone, everyone in class. Okay, so don't do this. Don't do this. Okay, even though you have a right answer, I'm sorry, you still get 0. Is that clear, everybody? Okay. All right. 0 points. 0 point. Okay, so let's continue. Let's continue. So I hope by this time you got the hang of it. Right, so you continue to do this. I want to give you a couple minutes to finish. Anybody want to show your work? Anybody want to show your work? In this case, in these cases, right? What is really useful is here. This stuff. Either the unit circle or the curve, really. Okay. You may not have those pictures in front of you directly, but in your head you have those. You have that. I urge you have, to have this in your head by, I have certainly tried to implement that into your head, right? By giving you homework, letting you plotting the points and so on and so forth. I certainly have tried to make you to do that, but you have to make yourself to do that. You have to make yourself to do that. Do you guys follow me? Okay. And now, what do we get here? 5 pi over 3. This is a counterclockwise measurement from standard position. Where will be the terminal? Where is the terminal? In the fourth quadrant, right? Is it in the fourth quadrant? Is it in the fourth
Yes.
quadrant?
So it satisfies the requirement.
Which one satisfies the requirement? Requirement of what?
The range.
The range for what?
Arc sine.
What is range for arc sine?
Negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2.
So okay, can you make a complete sentence? I'm not sure I understand what you're saying. You can type it if you want to. Speak it is fine, but I don't quite follow you. When you say satisfy some condition, the condition for what? What condition? What is the condition? A condition is for what? Do you mean this one?
Yeah, exactly.
You're telling me 5 pi over 3 satisfy that condition? Is that what you're saying?
Oh, no, it doesn't.
It doesn't. So what you do there? Even though 5 pi over 3 terminates in the fourth quadrant, it doesn't satisfy this condition. What I was saying is that you apply definition, the terminal in the fourth quadrant. And what is the reference angle? The reference angle is pi over 3. Yes? And therefore, this equals what? Negative root 3 over 2. Right? You're getting a negative ratio. And this quantity is in the domain of arc sine, which is between -1 and 1. And the answer for that would be negative pi over 3. Okay. You can also do this though. I'm trying to guess what's on your mind. Of course, it's usually is fruitless. Okay. You can use this. I don't know if you guys understand what I'm doing here. Okay. These two angles they share the same terminal. They share the same terminal, don't they? Do you follow me? Does everybody follow me? I don't know if that's what you implied. I'm not sure, but I want to point it out. Okay, this is also the beauty of using definition. Okay, this also reflects the meaning of using definition. So I'm gonna bring this one over here. Okay, bring the quadrant up, bring this over here. Okay, so you can see how important it is to use a definition. You really don't need to memorize those numbers, guys. You really don't need to memorize those numbers. Your effort should be focused on using definition. Okay. 5 pi over 3 is a measurement counterclockwise. Okay, and the terminal, that's a terminal. Yes? And the reference angle is pi over 3. But if this angle measure, if this same terminal measure from the standard position, the smallest, opening would be negative pi over 3. So this is a negative pi over 3. And this is 5 pi over 3. These two angles share the same what? Terminal. And of course, they share the same reference angle, right? And then they share the same definition. And also for this one, you can use that property. Do you follow me? For this guy, you can use that property. Do you guys see that? Arc sine. Arc sine of sine equals to x. And for that condition, which is between negative pi over 2 to pi over 2, pi over 2. Negative pi over 3 is in that interval. Do you follow me? Therefore, for this quantity, we can apply this condition. Do you guys see that? Do you follow me? You don't have to do this, okay? But I just want to point it out is that if when you apply definition, you're going to get all kinds of interesting phenomena, and you're going to observe. If you just take your mind away from the memorization, you say, okay, I'm just going to use definition. I'm just going to use definition. I'm just going to use definition. Go ahead and use it. You'll be rewarded so splendidly, so amazingly. You follow me? And the same thing can be said about the question we just did, number 21. Or number 17, or the ones we did. You guys follow me? Okay, so let's look at the last one, 25. Does everybody follow me? So this is what I mean, there's more than one way to do it. There are more than one way to do it. Now we already have 3 ways to do it. Right? Each one give us some kind of insight. Okay. Learning mathematics is about how you can be flexible. It should not get us more rigid. And that loses the whole point of studying mathematics. Mathematics is supposed to open our mind, not close our mind to other methods. Okay, so you always try to seek out other ways. Why we try to seek out other ways? Because it will open our mind even more. It gives us a very good mental training, logical mental training. And in the end, you'll find that your focus is really on one thing and one thing only. There's that a constant in that changing question. You may have 1,000 questions. I can easily give you 1,000 questions for Trig 7. Okay, in fact, I have 7B optional for you. Encourage you to do. I can give you 1,000 questions like this. But if you focus on definition, piece of cake. Piece of cake. Okay. The other way of study I wish to share with you, we're going to take a break shortly. I wish to share with you is that what I find effective that works for me, it's not about how many questions I do. Okay. It's not, I'm going to do 10,000 questions, right? No, I don't need to do 10,000 questions. I do 10 questions thoroughly. That's the trick. If you want to make that list shorter, what you do? You study those basic concepts when you get to calculus class, okay? Just like what we do today. You don't need to do 10,000 questions. You don't even need to do 1,000 questions, but you want to do 10 questions, maybe even 5 questions thoroughly from every possible perspective. You think through it thoroughly. And that value is about the same as do 10,000 questions day and night. And of course, the key word is thorough. What is thorough? Right? What is thorough? Thorough, of course, it's a word that's not, or very difficult to define very clearly, because the word thorough may be different for different people. Okay, and here I still want to bring your attention to ARD. Really, it's ARD. For me, when I teach this class, right? I teach Trig class. How do I conduct my classes? My focus is definition. When I conduct all of these classes, my very focus is definition. We went through all these functions. What is my focus? Tell me. Definition of function. Did you notice? Did you notice that? Did I tell you the theme of this class is function? What does that mean for you? What does that mean for you? We learned this definition. We learned this definition on the first day or second day. And we apply it over and over again for different rules. So until that definition is just like, yeah, of course. Right? Of course. Anyway, let's take 10 minutes break and we come back, we work on cosine. And hopefully we can get to tangent as well, okay? Take a break. Very good job, very good contribution. Keep your question coming, please, okay? Keep your question coming. So I'm gonna pause the recording and I'm just going to take, let's do the cosine. Okay, do you have any questions about sine in these sections? Mikhail says number 4, and I'm sorry, I didn't follow that. That was much earlier. What did you mean, Mikhail? You probably meant the quadrant, right? I think you probably meant the quadrant. I think you knew what's going on. Is that right? All right. We emphasize the importance of definition. Okay, so let's look at cosine. Okay, for cosine, of course, the overall scheme that it's about, you know, I put these over here for my convenience and also for yours. And I hope you have written these down and truly understand them, okay? Truly understand them, okay? I'm not inviting you to memorize these things. there's no need to memorize if you understand. That's why, truly believe. Okay, so for arc cosine, right? All the information you need to know, they're all here. Okay, but I'm not soliciting, I'm not trying to press you guys to memorize. Memorization of these facts is a battle you don't want to get in. Okay, because one moment you remember one thing, and the next moment you think you might have remembered the wrong thing. I don't know about you. Okay, so for me, it's hard to trust my memory. Maybe because I'm old, but even when I'm in my younger years, I don't think trusting my memory is a good idea. Okay, you always want to have a system to check your facts, to check what you believe is true. Okay, so let's look at the cosine. For cosine, I'm going to pick some questions. Okay, I'm going to pick some question. Number 3, number 4. Number 3, number 4. Seven and 8. 12. 16. 18. 22, 26. 22, 26. 8 questions. 8 questions. Okay. Number 4. Okay, I want you guys to think about these questions, okay? All right. Arc cosine. So this is number 8. And this is going to be negative pi over 4. All right. What do you think? Okay, so let's do the first 4. Let's do the first 4. Okay, with all the facts we know about cosine, arc cosine, domain range, and the perks, right? You can take, you just look at them, right? You don't need, this is not a test. Okay, you look at all these facts in front of you. Okay, with all the understandings you have gathered. Number three. Number three. All right. How come there's no comments? Are you guys there? Some people left. Yes. Cortland, you about to say something? Number three is 4/5 because it meets the condition of that conditional statement where the input of arc cosine has to be between -1 and 1. That's right. Okay, very good. Okay, so this condition is satisfied. Okay, that condition is satisfied. Okay, with that condition satisfied, it equals to 4/5. Okay, but what if you don't remember this? You say, oh gosh, I don't remember that condition. Only Cortland did remember, right? No problem. Go by definition, like what we did. Okay, so you can apply this you can apply this property directly. Okay, because 4/5 is in the specified condition, satisfy the specified condition. Okay. And next. What if you don't? Right? What if we don't? You want me to go over that with you? Yes? If we don't remember that, right? Okay. Or, okay, we understand arc cosine we need to understand arc cosine takes input ratio. Okay. And that ratio has to be where? What kind of ratio has it to be? The ratio
X
has to
over
be
R.
less than or equals to 1. Okay. And what angle does it produce? What kind of angle does it produce? What's the range of arc cosine?
-1 to 1. Oh wait, arc cosine.
Arc cosine. What does that picture tell you? What did it tell you on the unit circle?
0
Right?
to pi.
Sorry?
0 to pi.
That's right. 0 to pi. What is 0 to pi? First quadrant, second quadrant, measured counterclockwise, right? Right? That's what it is. Okay. So knowing this is an angle, understand the domain and range for arc cosine. So you assume this is be an angle, and this angle will be where? From 0 to pi. Okay. And that picture tells us that, right? The output is from 0 to pi. Do you see that? The output is 0 to pi. Input is from -1 to +1. Right? A picture tells 1,000 words. Okay. And then, and of course, your angle is measured from the standard position counterclockwise, right? That's the only way to measure the angles for arc cosine, counterclockwise. And this ratio is what? It's a positive ratio. Therefore, your terminal is going to be where? Your terminal is going to be in the first quadrant. It's not a special angle, no problem. And this is theta. And so it's measured this way. ARD. Terminal in the first quadrant. Okay. 4/5. Adjacent sides over hypotenuse, 4/5, right? If you need to mark those. Okay. Now. And we want to know cosine. With that introduction, we have a cosine of arc cosine 4/5, right? And that is already determined to be cosine of theta. And of course, cosine theta is 4/5. Right? So even if you don't remember that, you know some basic fact about, sine, arc sine, or what kind of input it takes, what kind of output is expected. You still get there. You follow me? Okay. So let's look at number 4. Number 4 should become easier now, right? What's number 4? Number 4 is similar. Okay. So that identity still applies because the conditions are satisfied. Conditions are satisfied. Okay. Let's look at number 7 and 8. 7 and 8. What does 7 equal to? Look at those pictures. Look at those notes, in front of you.
Is it pi over 3?
That's right. Why? That condition is satisfied, right?
Yeah.
How about 8 then? Each case doesn't satisfy, you just have to go from inside out. Or you go by ARD. Just go by ARD. Okay? How about number 8? Does this equals to negative pi over 4?
I got 3 pi over 4.
You got a different answer. Okay, Corman says pi over 3. Okay, that's for a different answer. The second row, you said pi over 4 and 3 pi over 4. Do you mean that?
I changed my mind.
You must.
Yeah.
You must. You have only one answer. You have only one answer. Okay, you cannot have two answers because it's one-to-one function. This will be what? This will be 1. Why? Because negative pi over 4 is outside the range of arc cosine. Okay, negative pi over 4. This is a very common mistake. Okay, is outside the range of arc cosine. Okay, the range of arc cosine is between 0 to pi. If you have an answer outside the range with the proper number in the domain, you're always wrong. That's a very easy to grade for me. Okay, because you look at the big picture, right? Arc cosine. You look at the arc cosine. Whatever this is, okay, I'm going to cover this. I'm going to cover this. Okay, I'm going to cover this. I'm going to cover this. You don't need to know this. Do you follow me? Arc cosine of something, if this something is in the domain, the answer must be in the range. If it's outside the range, it's 0. 0. Arc cosine is a little bit different from arc sine, okay? The range of arc sine is between negative pi over 2 to pi over 2. But arc cosine's range is between 0 to pi. Okay? And the same differences exist between tangent and cotangent, arc tangent and arc cotangent. Arc tangent is between negative pi over 2 to pi over 2 exclusive, and arc cotangent is between 0 to pi exclusive. Make sense? Do you guys follow me? We didn't do cotangent, arc cotangent. Okay, you are expected to do it yourself. Okay. And when it's necessary, I can do it for you, but we just haven't designate time for it. Okay. So you should know this answer is wrong because negative pi over 4 is outside the range. So don't make these mistakes. Okay. Don't confuse, in other words, arc sine and arc cosine. Their range are different. The range are different. Okay, the range are different. Okay, that's number 8. What do we do? There are many different ways to do it. You can go by definition. Okay, you can go by definition. If you guys are familiar with the even odd of these functions, we didn't talk about this in this class, but if you took trig classes, if you were familiar with even odd properties, that's also another way to do it, which make it much easier. But in the case you're not familiar with or you've forgotten about it, that's okay. Okay, I'm gonna spend some time with you on that. Is cosine negative pi over 4 is the square root of 2 over 2. So the final answer would just be pi over 4. Okay. That's number 8. We have 5 more. Okay, I'm gonna do 1 or 2 of them. Let me do one to see if you will try the followings. Okay, number 12. Okay, let's see what's number 12. Cosine arc cosine of negative 4. I will do one more for you, and then you may like to try your hands on them. Number 16, arc cosine. Cosine. What about number 12?
It's undefined
Because
because it's not in the domain.
what is not in the domain?
-4.
In the domain of what?
Arc cosine.
That's right. I want a complete sentence. Okay, you just say, well, it's undefined because negative 4 is outside the domain of arc cosine. Okay. When you answer questions, you always want to make sure your words and your sentences is complete. It's complete. Okay, so it's undefined because negative 4 is outside of the domain of arc cosine. That's an easy one, right? Number 16. How about number 16? Yes, number 16. Bailey said arc cosine 3 pi over 4 fits the condition. That's perfect answer. Very good. Very good, Bailey. Okay, it fits the condition, right? It fits the condition. If, you know, you understand that whole process and then it happened to be so handy, you have this question in front of you. You see, you understand that inverse relationship and you happen to remember this. What if you don't? What if you don't? Well, you do go by definition, ARD. So ARD really is the ultimate backup. Okay, ARD really is the ultimate backup. Okay, so let's look at 18. Let's do 18 though. Okay, even though we're going to I'm going to leave 2 questions for you. I'll give you some time to do it yourself independently because I don't want to take all the opportunities away from you. And we have a negative 3 pi over 4. And this time for sure it's not, right? Go ahead, someone wants to say something, I'm sorry. Did someone want to say something? Did I cut you off? What is the arc cosine of negative 3 pi over 4? Can we still apply this property? I'm afraid not, right? This is a negative angle. This is a negative angle. To satisfy this condition, it has to be between 0 to pi. Is it pi over 4? Are you guessing or you have a reason for it? Can you show me your reason? How do you reason through this process? Andy, thank you for your contribution. I'm not about to tell you yes or no. You have to give me the full reason. Between 0 and pi. Surely your answer is going to be between 0 and pi. But there are many, many angles between 0 and pi. So what reason do you have to support your answer as it's going to be equal to pi over 4? Yes, pi over 4 is between 0 and pi. But why does that make the right answer? This angle is measured. Okay, this angle is measured clockwise, isn't it? This answer is measured clockwise, right? It's measured clockwise. How is it measured? From the standard position, that's A, R, R. Okay, you measure from here and you terminate where? In the 3rd quadrant. And this angle is negative 3 pi over 4. Okay. And then the reference angle come to the picture, right? And then what? And this is going to be arc cosine. By definition, this is going to be negative root 2 over 2. Sorry. Never mind. Okay. So what will be the answer here?
3 pi over 4.
Sorry?
3 pi over 4.
That's right. It's 3 pi over 4. Not a pi over 4. Okay. And once again, you need to understand that arc cosine, the answer, right? If you just cover all of these, and you should know what to expect. The answer is going to be between 0 to pi. Pi over 4 is a nice try, but you have to verify the details. Okay? Your answer definitively is going to be between 0 to pi. This symbol there tells us what to expect. The range tells us what to expect. The range tells us what to expect. Could I emphasize that enough? Right? Domain tells us what can be the input. The range tells us what can be expected. All right. So, any other questions? For those of you who know, this is, this is a even function, right? This is an even function. Cosine is even function. And you can also go that way. I will save that for later, for another time. Okay. So would you like to try the next two questions before the end of the class? (22) and 26. (7 pi over 4) and 26. So we cannot use that property, right? They're both outside outside that condition. Outside that condition, we cannot use them. So what do? Same way. Okay. So I'm gonna give you I'll give you a little time. Okay, I'll give you a little time to work on these and take your time, and I will catch. I will give the answer before the end of the class. Okay, I will give you the answer before the end of the class. So I'm gonna stop share for the moment. Did I stop share for the moment so you can work on it? I'll bring it back. Okay, I got I got a message from Pronto. Okay, let me see that work. Oh, she sent it to messages.
Wait, I'm sorry, what questions do we do again?
I thought we are doing 22 and 26. You're
Okay, thank you.
22. You're 22. You have 7 pi over 6. Did you write? I think you copied that question incorrectly. Your answer
Oh,
is
sorry,
right.
I meant 4. 7 pi over 4. Sorry.
Yeah, you write 7 pi over 6. That's not correct. Okay. And that the way you write it, you should remove the second line you sent me. You
Mhm,
don't need to mention that. Just put equal sign next to the first line
mhm.
and then follow that. You follow me?
Yes.
You don't need to mention that doesn't satisfy. You don't need to
Okay.
mention that. Okay.
Okay.
I'm just telling you, when you show your professor, you don't have to tell her everything. You don't have to tell him everything. You just need to give her the right thing.
Okay.
Okay. That's the principle you want to follow when you're here in El Camino or you go to 4-year school. Okay. Just give the right steps, like what I have shown, like what I have shown on the board. Okay. So do you want to share my screen?
Yes.
Just write it like that. Nice and clean. Okay, nice and clean. If I'm in the classroom with a board, I would write it by my hand. I would write it like this. I type it because I can. I think typing is even better for you to read. You don't need to tell professor that, oh, I have checked this condition, it doesn't satisfy. No need to tell her, no need to tell him. All right. Okay, so that's number 26. That's number 26. Okay, did you get the same answer?
Yeah.
We don't have enough time to cover tangent and cotangent, but I do want you guys to try them, even cotangent. Okay, because I do have a couple questions on cotangent. Cotangent is not it's not completely out of your future work, because you might still encounter it in calculus classes. Okay, so I still put them there, so you will have some idea. But in general, it has some similarities to what we did in class. That's why I didn't, I haven't designated any time to go over that in class. Okay, so at this point, I want to tell you about, some other stuff, you may like to know. As a student, especially you have, you guys are going to pursue calculus classes and all of these. As you pursue this higher and higher, the expectation is higher and higher. Okay, you should not be just satisfied with you have done the homework. You should try to do a bit more. You try to do more. Okay, I know the tendency, even for my own children, right? When they were in high school and the teacher assigned them like 1, 3, 5, 7 questions, and they will not do 2, 4, 5, 6, 2, 4, 6, 8. To me, why not? I don't know why people have that kind of mentality. Of course, it's maybe generation gap or whatever, culture gap or whatever. I noticed that with my own children. Did I make them? I probably didn't. The teacher will assign them 1, 3, 5, 7, 9 because there's answers in the back of the book. I'm not I think I tried to be a tiger mom, but I'm not, right? I wasn't able to make them to do the way I want them to. And I just bring this up, I want to mention it to you, okay? Not with the intention I'm going to make you, because I couldn't even make my own children. But what I do want to tell you that you do need to go to that a little extra mile to make it. Do you follow me? Maybe you don't have to, I don't know. But it's better to be on the safe side, isn't it? So even though I only asked you to do the A's, I didn't ask you to do the B's, but I still secretly wish you will do some of the B's. Yeah? It would be better for you. It will be good for you. It will be good for you. Okay, we're close to the end of the class. I find it, at my age, sometimes you feel like you have a couple of wisecracks. It's always so much easier to work on ourselves than work on other people. I don't know if you agree with me or not. Sometimes we wish the world to change to the way we want it. And in the end, we realize it's much easier to work on ourselves than work on others. Even though working on ourselves it's not an easy task either. But it's still much easier. It's still much easier. Okay. So without further ado, I think I will ask you to continue to do the homework, but I will also ask you to think about Trig 8. So I'm going to give you homework on Trig 8 today. Not expecting you to finish all of them, but I want you guys to have a head start to get started on this. Okay, and also go through the pages of this handout, because what we have covered so far really allows you to do majority of the notes. just basic one. You know, see, we've been just doing basic one, right? I assign you homework for later sections. But with this kind of coverage, you should be able to do a lot of these handouts. But you don't wait. Don't wait, say, oh, I'm gonna wait for professor to do page number 37. No, you should not wait for me. Time and tide waits for no man, no woman too. Okay, you need to have some kind of urgency to better prepare yourself for the calculus classes, if that's where you're heading. And if you have any question about anything in this here, please don't hesitate to reach out to me. Okay, so I will see you guys on Monday, if not sooner, but please do expect another quiz. Okay, please do expect another quiz. I will have another quiz for you. Okay,
Thank you.
so have a great weekend. I'll be in my office hours soon.